All right, year 12s, let's have another look at an example of determining probability distribution. In this case, in this example, we've got a non-uniform example. This is non-uniform. This tells us that the probability of each event is not the same. We have a changing or varying amount of probability for each particular variable. So let's have a look at the example here. Robin is playing a board game and must roll a 6 on a fair die or dice before she can proceed. So she has to get a 6 before she can start the game. Let X represent the number of times that Robin rolls the die to obtain that 6. What is the probability distribution of X? Okay, so it's a bit of a weird one. We're going to start off by doing a table, but think about it. Robin has to roll a 6. She might roll a dice and land on a 1, and then a 3. She might roll a 3 again. She might roll 3 3s in a row, then gets a 4, then a 1, then a 5, then a 1, then a 2, then a 2, then a 3. Can you see it's, unlikely, but it's possible. It is possible mathematically that she never rolls a 6. So we can't define our probability distribution with a box that ends, because how many times does Robin have to roll the dice or die before she can continue? Well, she might have to roll the dice 3 times or 4 times or 5 times. She might have to roll the dice, infinity times. So we can't use a table. Well, we can use a table to help us, but what we're going to do in the end is not make a table for our answer. We're going to make a rule that defines what's going on here. And I suspect there's going to be a pattern that will emerge, and that pattern will be the rule, which will define our probability distribution. So let's go ahead and do that. I will start off, however, with a box, but it's going to be open-ended. So watch me as I do this. Kind of like this. This. Like that. So it can go on for ever and ever. I'll put another straight line in here. And I'll do this. On the top will be our sample space. On the bottom will be the probability that our variable is that sample space, or each one of those sample spaces. So here we go. Now, if X, or the little x, is our sample space, that means that we're going to start with the number 1. That means rolling 1 dice and landing on a 6. Remember, letting X represent the number of times that Robin rolls the dice to obtain a 6. This means that Robin rolled a dice only once and landed on a 6 immediately. So what's the probability of rolling a dice and landing on a 6 in one go? Well, it's 1 in 6. It's 1 in 6. Okay. 2. That tells us that it took her 2 goes to land on a 6. So what's the probability of rolling the dice the first time and not landing on a 6? Because here's an example. She could have rolled a 5 for the first go, right? And then for the second go, she rolled a 6. So the probability of the first roll of not landing on a 6, well, it's 5 out of 6. Because there's a 1, a 2, a 3, a 4, and a 5. That's 5 out of 6. And then the second one, the second roll, we know she landed on a 6, so it's 1 out of 6. But what's the probability of both of these events happening? This and this. Well, in maths, and means times. So that's what we're going to write. We'll do our 5/6 times our 1/6. Let's recap. So to roll a 6 in one go is 1 in 6. To roll a 6 in 2 goes is 5/6, because that's when you got anything but a 6. and then the second roll, which got you a 6. You'll see after the third roll, there's a pattern that emerges. After the third roll, well, again, the first 2 of those 3 rolls, she has to get not a 6. So that's 5/6 times another 5/6 for the second roll. And then for the third roll, it'll be the 1/6, because that's her getting the 6. Can you see a pattern? We'll do one more. So for 4, let's use a straight edge for this one. For 4 goes of a dice, that means that she had to roll 4 times to get a 6. Well, the first time she rolled, it didn't work. The second time she rolled, it didn't work. The third time she rolled, it didn't work. But the fourth time she rolled, she got that 6. And the probability of rolling a 6 is 1 in 6. Can you see a pattern here? Because I can. Let me just delete. I'm just going to delete this part here. Can you see the pattern? The pattern is this, and this is our probability distribution. It's going to be defined as a rule, not a table this time. The probability that X, the number of times that Robin rolls the dice in order to obtain a 6, is definitely, have a look, there's always a 6th, right? No matter how many times she had to roll to get a 6, whether it's 1 or 2 or 3 or 4 or 88, there's always going to be that 1 in 6th chance, because that's what she needed to get the 6 in the end. So there's definitely a 6th. And we're going to multiply that by, when it took her 1 go, there was 0 5/6. When it took her 2 goes, there was 1 1/6. When it took her 3 goes, there were 2 5/6. And when it took her 4 goes, there were 3 5/6. Can you see the number of 5/6 in each box is always 1 less than the number above? So this is how I'm going to represent it. I'm going to represent it like this. 5/6 to the power of, right? This will tell us how many times we're multiplying this by itself. To the power of whatever number this is, so X minus 1, 1 less. Because let's take this example here. If X is 3, well, looking at this rule, to define how many times we multiply by 5/6, we minus 1. 3 minus 1 is 2. And so that gives us the number of 5/6 that we multiply by. So this is the rule.